Let us continue look into the chapter 2 of the proposal. In the previous video, we look into a data set. What does the cybersecurity intrusion detection data may looks like? And we also have a very brief introduction about the feature selection so that we would be able to see based on the data and the preparation parts, how can we apply different data mining techniques to find informations, to make predictions or make descriptive informations about the data. The proposal has another three major sections in this chapter. One is about the classification, clustering, and association rules with correlation. Since most of these algorithms has been discussed in our data mining class, I'm only picking up the important aspects of the things that I want to discuss with you guys and spend a little bit more time on the association rules to refresh your memory, since this is highly related to the next chapter. So let's look into the classification. Ideally, for the classification is that you try to build a model from your training data set and then use that model to predict testing data set. So in this figure showed in the proposal is using the learning step that provide the learning algorithm, no matter what are the learning algorithms that we want to do. For example, if that's a decision tree, then we look into the decision tree. If that's about the SVM, we use the SVM learn steps to work with it. We also feeding the training data set. So in this case, the red dot indicating the anomalous or the attack traffic, the green one indicating the normal traffics. So that in the training step, using the models that we have, we train a model based on the chosen algorithm as well as the training data set. And then we use that model to do the classification step. So at this time, we will have some testing data set that feed into the model that we have, and we try to make the predictions out of it. So this is the general structure of the classification approaches. And of course, in our data mining class, we have substantial discussions regarding to the decision tree, naive Bayes, support vector machine. And if you take AI class, the artificial neural network has been heavily discussed in the AI class. Today, I actually want to look a little bit deeper into the Bayesian network, because there are some similarities between the Bayesian network and naive Bayes ideas. They all using the probabilities to work on things. However, Bayesian network has a little bit different concept with the naive Bayes. Let's take a look at it. Bayesian network is a probabilistic model to represent the dependency between features using a graphical idea, which would looks like a tree structure. So what they're trying to do is that, unlike naive Bayes, if you still recall the naive Bayes, we treat every single dimension, every single attribute independently. So that when we try to calculate an naive Bayes probability, we use each attribute to associate with the label. And then for every single attribute, we can calculate the probability of go into a positive case or a negative case. In terms of the application of the cybersecurity, positive case can be specified as the attacks, and the negative case can be considered as the normal traffic, and different dimensions is associated with different attributes that we have in the data set. Bayesian network do this differently, so that Bayesian network reveals the nature dependency between them. So the concept in Bayesian network is saying that probably all the attributes are not totally independent. Some of them is related to others. So maybe attribute 1 and attribute 2, the combination of that will result into certain values of attribute 3. And attribute 3 may also affect the final label. So that how do we using the correlation between the two attributes or more attributes together to form a network? So this is the Bayesian networks idea. Bayesian network encompasses two key components to express the relationship between features, and then they use a directed acyclic graph and conditional probability tables. And what that's trying to do is better to show you an example. So I actually go to the website, and I find this website has a very nice example to let you know what kind of basic networks looks like. This is the pictures of the example that I want to discuss, but actually I want to go into the website directly because that can give you some interactions. So take a look of this one. This is what they call an Asian network, so that these are the different attributes related to the problems that we want to look into. So you can see that the final problem over here is dyspnea. So what that means is difficult to breathe or labored breathe. In this class, so you can see there's a true and false class over there. To reach this final step, you need to go through all of these attributes, so that each attribute has two places to start with. The first one is visit to Asia, the next one is smoker. So take a look of this. What 1% over here indicating visit to Asia means that in the data set, there's 1% of the data or 1% of the people that has went to Asia. 99% of people did not went to Asia. The same thing over here for smoker and non-smoker. So that true is 50%, false is another 50%. So all over here is indicating that what is the overall percentages on each attributes. And that will lead to the dyspnea for true with 43%, false with 56%. On the other side, there's also another leaf node indicating X-ray result. Abnormal is 11%, normal is about 88%, close to 89%. What this basic network interesting is that you can actually interact with this one. These are the probabilities of the training data set. But when we have a testing data set comes in, so that say that person is a smoker. So what this interactive window do is that you can really actually click that, indicating that this case is a true smoker. And at the same time, you can see all of these values are changed. This is what I was talking about. Smoker is actually an attribute. It is going to affect the other two attributes, has bronchitis as well as lung cancer. And in this case, you can see that if we select is a smoker and then that person has a lung cancer, when I click this one, you can see that this has become changed to 100%. X-ray result abnormal is 98%, as well as the dyspnea has 82% true. So all of these are related to each other, and then that will go to the end results that we are looking at. And therefore, this model is actually a very good study in terms of this kind of correlation between the attributes. They can really link all the attributes together. And of course, the difficult part also is how do you design this? Because this may require some doctor's ideas to see that, okay, this one goes to this two, this one goes to this one, and you can see the tuberculosis or the cancer is actually infected by two different attributes. The same thing with dyspnea, they were affected by these two attributes, and at the same time, these two attributes is affected by other attributes. So it's actually forming a network. And in the end, when we have typing or provide the testing data set information, we can use the percentage between the truth and false to make the predictions out of it, just like when we were doing the naive Bayes. So you can see that there's a lot of similarities between the two, but of course, basic network requires more time to do the training to build up this kind of model. And what I'm trying to think is that this is also something interesting that we can think about or do in the wine informatics data set, because the quality of the wine can be related to fruity, the body of the wine, etc., many different things. And each one of that is also affected by multiple attributes. So that how do we make our original attribute, 900 something attributes, into a figure, a network like this is also a very interesting thing. And by changing the graph configuration, they may end up with different results. Maybe can generate even better predictions for the quality of the wine or the region of the wine or the left bank, right bank, even the wine is drinkable or need to be held for a certain amount of years based on their review. So that there's a lot of different things that can be described over here. And therefore, I do feel Bayesian network is a very interesting one to look into. The next major areas of the cybersecurity, as we discussed in the previous video, is about clustering. So that in the data that we may have a lot of data over there, and we can apply some clustering approaches over there to divide that into, say, several groups. Maybe some groups is in the uploading the data category, the other one is downloading the data, and one group of the data might be try to change in something, make some different configurations, and that might be correlated to the attacks or something. And therefore, clustering is also some very useful techniques in the cybersecurity or intrusion detection problems. Finally, we come into the association rules. Association rules mining is an interesting field of research in intrusion detection system. There's actually quite a few papers or researches applied. If you read the proposal carefully, you can see that for every single algorithm, there's actually a lot of different papers, a lot of different research has been done in this field. And that also gives you an idea about how would you write a thesis or write a dissertation. You need to have some references, and you need to look into a big picture, go into a smaller dots, and then each one will have some references to show that, okay, you do know the field, you do know what kind of things has been done in these areas, and then you try to see what's the something new that nobody has ever been worked on. So this is usually like a small area, but if you can make some breakthrough, then maybe other researchers can benefit from your findings. So the objective of using association rule mining is to extract interesting patterns from the large data set based on some predefined measurements. And you know the rules generated by association rule is like A and B goes to, say, positive attack, or A plus B plus C goes to a attack, something like that. So those kind of things, the rules generated by association rules are very easy to read, very understandable, and usually they are pretty simple to be analyzed. And therefore, association rule is actually a very good application in the intrusion detection area. So association rule mining also facilitate defining meta rules to detect instances of future attacks. The idea is this: even though the attacks are some day zero attack, the goal of this approach was to identify any novel attacks from some signature of the previous attack based on the assumption that any new attack should be related to a known attack. They may have some the similar starting procedures to goes to a certain point and then initiate some new attacks. And if we are able to capture those initial signatures, then we might be able to get an alert and then try to shut down the system in time. So there are many different applications can be used through the association rule mining. So to refresh your memories about association rules, it tries to calculate two most important parts of it. The one is called a support, the other one is called a confidence. The support indicating how many times of the A and B occurs together through the total amount of transactions that you have. For the confidence, A to B indicating that you want to find how many times A and B occur together under the situations when A occurs. So let's take a quick look of this part. The examples that we used in our data mining class is this one. There are 9 transactions, each one try to purchase something. And you can totally transform this idea into the cybersecurity data set. One may be using TCP, 2 may be like guessing the password. 5 can be like they have tried to stay in the network for more than 2 seconds. These kind of things can be categorized into different numbers, just like when we were studying the association rules. And based on this one, we will be able to see that first of all, we need to define our minimum support. Say minimum support is 2/9, and minimum confidence need to be greater than 60%. So what we were trying to do first is that for every item, because we have 5 different item set, which means that there are 5 different things can happen over there, we try to count how many times it occurred. Since our minimum support is 2 out of 9, then all of these survived. When they survive, they will need to interact with each other to generate a 2-item set, and then using the 2-item set list, go into the data set, try to find how many times do they occur, and of course, the one that does not meet the minimum support will be filtered, and now we have all these 6 different 2-item sets, and what we need to do next is that using the cross mutating to each other so that we generate a 3-item set, and then in this case, all of the both 3 items that are survived, so that we would be able to stop over here because we know there's not enough rules for us to generate a 4-item set. This is what we can do about the support using the a priori concept. And of course, after this step is done, for every single rules that has passed the minimum support, we need to calculate their confidence. And therefore, you can see that this is the pseudocode of what we have seen to do the a priori concept. And then to calculate the confidence, now the direction matters. Strong association rule means that the frequent rules, which means they pass the minimum support, that also pass the minimum confidence. And therefore, we need to go into each item and then try to calculate their confidence. So for the confidence 1 to 2 equals to 4, that's how many times 1 and 2 occurs together, divided by 6. I occurs in 6 times. That's why I1 is less frequent than I2, and compare with the other confidence calculation, and since our minimum confidence is 60%, this one will survive, this one will not, which will say that when item 1 occurs, it will also goes to item 2. Similar things that you need to do for all the 2-item sets, that you need to calculate all of these things, and for the 3-item set, for every single 3-item set, you actually need to check 6 different combinations and then to see if they really occurs, and so that if they also pass the minimum confidence, then we can generate a 3-item set frequent association rules. There are several things we also discussed in the association rules, saying that we have 10,000 transactions. 6,000 of them by computer games, while 7,500 of them including the videos, and 4,000 including both computer games and videos. So now the idea is that in this case, since there are 60% of the customer who buy the computer games, 75% of the customer buy the videos. At the same time, say 40% of them buying computer and videos. Does that mean people who buy computer games also buy videos if we set our minimum support, say, to 30%? Okay, so this is what we have discussed in our class as well. You can see that the people who buy the support saying that game and video is 40%, and this time confidence is actually 66%, which is pretty strong. So saying that if that is the case, do we say that people who buy the game will also buy the video? Actually is not the case. Computer games and videos are actually negatively associated. Why does that? How do we know that? We know that is because by nature, if we have 60% multiply 75%, which is 45% will buy both already. While we compare 45% with the actual situation, it's actually only 40%. That's how we can know they are actually negatively associated. Of course, this information will not be captured by the association rules because we only consider support and confidence in the association rules. And that's why we also introduce another concept, it's called lift. And lift is what we would be able to use to see that if they are positively correlated or negatively correlated. The way we're going to calculate is P probability of A and B purchased together divided by probability of A multiplied by probability of B. Exactly the same things that we used in the example. And therefore, if this is less than 1, then they are negatively correlated as our example. If they are greater than 1, that means they actually have some correlations between those. This is what the proposal discussed in 2.6, the correlation. So that combining the association rules with the correlation is actually a more solid way to analyze the problems, and this can totally be used in the cybersecurity area. So that in a sequence pattern mining approach, a sequence SA is identified in another sequence SOB if both sequences have some common set items occur in the same order that SB is greater or equal to SA. So finally, the assignments I want to give you guys for the class is that I want you to start reading about chapter 3. Chapter 3 is the main algorithms about this proposal. So I want you to write a paragraph about what is high utility sequential pattern mining. That's something new introduced over there. So what do you think that is? High utility sequential pattern mining, and I want you to submit that through the Blackboard. Of course, if you are interested in presenting chapter 3, every student need to present something in the whole semester. If I were you, I would want to do this as early as possible so that we don't need to worry about these presentations, especially in the beginning of semester. Is usually easier than the end of the semester.